that. Should we bring in our first moderator?
Let's bring in Rob. So Rob Reid, some of you may know him. He's been part of the ecosystem for many years. He's a big technology nerd like I am, like we all are. And we are, Rob came across our vortex many years ago because he actually wrote a book about distributed SQL, which happened to talk about Cockroach DB a little bit. But we found it so unusual that he has all of his favorite technologies up and down his arm. So we've got a whole, I just went through the list. You've got the Gopher from, Golang, you've got Redis, you've got a whole bunch of really cool technologies on there, the blob. So we'll see as he talks with his hands if you can name that tech. But anyway, Rob is an author and a technical evangelist at Cockroach Labs. Just recently joined, by the way. We're just really lucky to welcome him to our team. And then Rob was going to be leading our panel. He will introduce, let's bring in Viviane and Chris. And then we're going to take a step back. So take it away, Rob.
Thank you very much. It's my great pleasure to introduce our panelists today, the very, very talented Viviane Costa, who's a lead platform engineer at Super Evil Megacorp. Viviane has more accreditations than any other human, I think, and is responsible for leading the platform team responsible for global phenomenon games like Catalyst Black and Vainglory. Chris is a senior software engineer at Xbox. He's an expert in all things orchestration, cloud native, service mesh, and instrumentation, and is a bit of a cloud native hero. So thank you both so much for joining me today. I think that between you both and your decades of experience, I stand to gain a lot. So it's brilliant from my perspective, but hopefully to all of our guests as well. So thank you so much for joining us. And welcome to the panel.
Thanks so much for having us.
So I'm hoping that today we'll explore what it takes to run a game in the cloud, what technologies that you both use to achieve that, and millions of concurrent users. How do you even? So I guess on that point, millions of concurrent users isn't a number that most developers will be familiar with or have typically encountered, at least historically, which makes your industry somewhat ahead of the curve in terms of developing for scale. What kind of challenges do you face when developing applications at this scale? And what kind of technologies do you use to solve those problems?
Yeah, I can start. So thanks for having me here, Rob. Nice to be here. So I think, yeah, absolutely. There are, I think very few industries that face, similar technical challenges that we have with gaming. So what we are talking here is really a large scale, application to support millions of concurrent users. They happen to be, most of the cases distributed across the globe. And for a lot of games, we also have high sensitivity to latency. So all combined is a, interesting technical challenge to solve. So I think all in all, the main challenge is to, how do we provide a great user experience, to our players at all times when we are scaling in an efficient and also cost-effective way. So I think there is a lot of, that goes involved with that. So there is a lot of that we have to take in consideration to build a scalable system that is reliable and that can provide, good performance to our players. So in terms of, tech stack, in architecture for Super Evil, I can mention a few technologies. So we use Terraform, we use Docker, Kubernetes, also, microservices architecture. We use CDN for static content, scalable database, of course. So I think, it's a combination of a number of things and principles as well when developing.
Very cool. So when you're dealing with, you've got a global user base who are using your applications concurrently. How do you harness the technologies that you've mentioned to achieve this level of scale? Because I've worked in environments where I'll be servicing a small group of users or maybe a slightly larger group of users, but they'll tend to follow the sun. I think in your model, especially when you look at spikes in games when they get released, there's massive spikes in interest and traffic. For games like Catalyst Black, what kind of traffic spikes do you see, and how do you harness Kubernetes, for example, to tackle that?
Yeah, so we really have to think about, where, the majority of our players will be based, right? And that changes along the game is not something that is static and it will be forever the same. So we have to be constantly monitoring. So decisions like, where we are going to have our clusters, which regions. So this sort of consideration. And also be prepared to change if things change, or in a positive way if your user base scale more than you thought it would. The region, maybe you notice that one region is not being as well served as you would like to. So I think it's just kind of, in our case, using Kubernetes to define the regions where you want to have your applications running. Not so it is also, in some cases, it is very game by game. One region will support that well, so it's very specific to a game and how that game works, how sensitive to latency things might be, and the different parts of your application as well, where you are going to run them. So it is a constant process, I would say. There is an initial setup that you decide to go with based on projections for like world launch and things like that. But then it is just actively monitoring and reacting, if anything is needed.
Yeah, so very much not a one size fits all for each game.
Not.
And I think probably Chris can attest to that, where you're responsible, I think, in a similar way to Viv at Super Evil, but at Xbox, you work in the platform side of the business as well. I guess do you face the same kind of challenges?
Similar. I mean, the one, I guess, major difference is that, like, for our services, once someone is playing a game, it's actually, we kind of get out of the way. And so, like, we find the closest server to the person who has the game that they're looking for. But once we get them there, our services actually aren't involved, except for to, keep it alive and stuff like that. But for us, like, we have more, I guess, bursty traffic that is, it's still fed similarly. Like Fortnite, for instance, we host that, and so when they have like a major event, we will have a huge spike, and those sorts of things we absolutely keep track of ahead of time and scale up just naturally. Then we also use like Kata for auto scaling, and obviously Linkerd in between, as a service mesh, and funny enough, we don't have an ingress controller, which is one of those things that, like, I feel almost kind of silly saying out loud, because it feels like, how could you not have ingress? But anyways, yeah, we essentially built our own. So as far as what technologies, we're using to tackle them, I would say, honestly, the things we've been kind of moving to are more asynchronous communication patterns, things like that don't require us to have like, a billion pods all kind of standing in the front line, but instead we can kind of distribute that work out a little bit fairer. And so, that's kind of one of the, I guess, the big things that I'm excited about us kind of progressing towards.
Yeah, definitely. So on the subject of, you mentioned scale, and there seems to be a split between using tools to achieve scale, but also preempting the scale, knowing when it's going to happen, and I guess probably scheduling in nodes as and when. And I guess that keeps your costs sensible, but also allows you to maintain that burstable scalability. What percentage would you say is of a game's scalability is based purely on the automation of tools versus you're having to monitor and know the schedules of the games?
I would say that right now, honestly, it's probably 60-40 automation to like manual intervention. And we're working to reduce that further. Right now, in the very early days, we kind of had some issues where we didn't really set our resource requests appropriately, and everything kind of fell over. And so we had some very hard lessons at that time. And so we kind of said, okay, we're just going to make sure everything has plenty of breathing room. And so now we're kind of like bringing that in a little bit through automation and stuff. But we found that things didn't quite work exactly the way we expected them to. And so I think we probably overreached to make up for that. And now we're kind of trying to undo some of those.
I guess it's better for you if you overreach and keep people happy than undershoot.
Exactly.
Yeah.
Exactly. Yep. And we have, the leeway to do that. And so, yeah, that is the way we've chosen to solve that problem.
There is also like, the initial days, after you launch a title where you're still learning things, right? So you definitely want to be more on the careful side and perhaps over provision just to kind of, understand, really the player behavior and how that translates into your application. And then rely more, on auto-scaling and things like that. So yeah, at least from our experience, that's how it goes.
So on the subject of scale for both of you, we've talked a little bit about the tools that you use to achieve the scaling and the burstable capacity. But what are some of the design philosophies that you just can't ignore when developing a system like this? Because as you say, you don't know, you can plug a game to the nth degree, but you don't know how successful it's going to be until it launches. And you might develop a game that struggles to gain traction at the start, but then really ramps up and suddenly skyrockets in popularity. What kind of design philosophies do you always keep at the back of your minds for those scenarios?
Yeah, in my case, I think, it's always, being the optimistic and thinking that, things will go well. And then you have to really prepare, for really large scale. And I think in terms of philosophy, I think it's really important to think about how your application would behave under exceptional circumstances. So not just the happy path, right? So to plan, to make things resilient to failure, to increase latency, even if you just return a code, right? An error code, sorry. So I think there are a few things, practical things like defining short timeouts, having retry policies on the different layers and integrations that you may have, considering patterns like circuit breakers, to really allow services that might be struggling to recover. Using, CDNs to offload some of the load on your systems and so on. So I think it's really kind of preparing for, large scales and, large numbers, and thinking really where things can go wrong and how do we prepare for that. I think in a nutshell. There is a lot of that, to be taken in consideration very early on in development,
Absolutely. And a couple of things I guess I'd add on there, I think this is probably a given, but I'm just going to explicitly say it, is like microservices, right? Like for us, it was very early on, chosen that like, hey, we're going to have, a ton of services, and, we're going to try to stick to the single principle. And those have really helped us. Like the times when we were like, hey, let's just kind of shoehorn this thing in here because it's somewhat related. Like we have been really unhappy. Like I would say probably 80% of the time that we did that, because we're like, oh no, now we either need to scale those things completely differently, or, for whatever reason, we're wasting resources. And so, yeah, like really keeping to the single principle is one of the things that I've really, I guess, been a big advocate of. Testability is another thing that I think that like a lot of folks, including us, probably don't take as seriously as you should. For us, especially with the scale, like we had to develop a whole system while, we were trying to like get people into our ecosystem for scale testing and stuff. And it was a lot of extra work that like, if we had put the work in up front, it probably would have been significantly easier.
Yeah, no, absolutely agree with Chris on the testing side of things. And I also think that, there is also some very interesting gains to be had with even some, basic load testing, right? Or performance testings in general. So there is an extent that you can decide to go on that. But there is always like low-hanging fruit that you can get with some, initial performance testing as well. So I think, of course, every circumstance is analyze what you can do. And I think the more the merrier. But there is, some interesting discoveries in that process.
So I've had some experience, limited experience of load testing in my career. What kind of tools do you use to load test a million plus user architecture? And do the tools that the layperson would be able to apply to your kind of workloads, do they translate, or do you have to build your own?
For us, honestly, it's interesting. I was there. I got there right after the decision was made to use Kubernetes, but I've been there for almost every other decision after that. And it's interesting to me that like we didn't really, to my knowledge, and I could be wrong here, but investigate a whole lot like what is the testing mechanism that most Kubernetes operators use, and yeah, so we ended up building our own, and basically it's just more recently I've become familiar with Locust, and so like we've used that to kind of do some really basic testing, but our auth flow and all that stuff was so unique. We were like, oh, we've got to build our own. But like, really, like we're all kind of now realizing that like, hey, there's a lot of stuff in the community that is like valuable for this, and we should really be leveraging in that. And so we've really had a renewed push, I guess, over the last couple of years to start looking into that. But it's really just kind of early days right now. We're still kind of just running this stuff that we came up with 4 years ago, and it's done well for us, but at the same time it's not sustainable. Like once things like change and we have to majorly re-architect, we're going to be in a lot of pain. So
yeah,
I guess open source tooling can only benefit there because you get the input from the communities. You mentioned Locust, there's Gatling, there's JMeter, K6, Work, Hey. There's so many amazing benchmarking tools that you can use.
Yeah. We use K6 a lot, and I think it covers a lot of kind of what was mentioned as maybe some of the basic tests that can really give us a lot of information. So we do, primarily, of course, we do rely on Kubernetes, auto-scaling and everything, but we still want to understand, what's the throughput, for example, that one pod in a specific, how the configuration can support, so we can easily do a number of, soak tests, try to see if there is any indication of memory leaks, CPU usage that goes more than we would like to. So these are some of the tests that we can kind of, I would say somehow easily set up with some of these tools, and, really give you a lot of information to prepare you, really when you are live.
Yeah, absolutely. Just for my benefit, maybe for folks who are less familiar with load testing, soak testing, that's a sustained high throughput kind of test, just to make sure, just to see at which point services start to wobble.
Yeah, so we want to see if in the long run there will be any behavior, like a memory leak. It might take a longer time to kind of be visible, right? We do a combination of soak tests with stress tests, and just to get different information. And then just observing things in general.
And you're looking at the charts to look for the dreaded sawtooth for memory leaks.
Yeah, and that goes into the observability aspect of it, right? We also want to exercise things, make sure that we have visibility on the things that we want to see anyway. So it is also a good test to see, I think we may have a problem here. How do I find out more? And then you combine, all the aspects of the observability to make sure that you can, really identify your issues and get to the bottom of things.
Yeah. You both mentioned Kubernetes there, and I'm sensing that Kubernetes is quite a fundamental part to your architectures. Since employing Kubernetes, what kind of benefits have you found from using the platform, and what kind of challenges have introducing these kind of, I wouldn't say cutting edge anymore, but these really up-to-date technologies in your tech stack introduced? Because they're not simple. You could probably get a PhD in Kubernetes nowadays. What are the payoffs, the trade-offs?
I mean, honestly, for myself, the thing that I felt, I guess, most refreshing about Kubernetes when I first got into it was just that, like, all of a sudden I had this common language that I could use with other folks. When I talk about a service, no one has any idea what I'm talking about. If I just am like, hey, I've got a service and it's doing some stuff, like, what does that mean? But like, if I say in Kubernetes, my auth service, is behind some load balancer or whatever, like all of a sudden that becomes more concrete, and I can talk about a pod or a container or, these things. And to me, that is huge. Like I now don't have to like have that like mental overhead of like, oh my goodness, this person doesn't work in our stack, so this is the equivalent of that thing in their stack. Like I don't have to do that. And so that is huge. And it like has made it really possible for, I think, for our team to really like move quickly and adopt it, because now we all have the same exact language, same understanding. And so that was huge. I mean, obviously, there's the whole technology of it, like everything that it does for you. But like, to me, that was the like first, just like hugely tangible thing that like I loved about it.
And in order to achieve that kind of standardized vernacular, I guess that's quite a wide rollout of Kubernetes you're talking about, in order to be able to say to anyone in your kind of sphere of influence, this is a pod, this is a policy, V1 beta, things like that.
Yep. Yeah, we do like, we have learning, like lunch and learns and things like that. And we talk about like, I've done a Cube 101 for our team a couple of times and things like that, to just make sure, everyone's on the same page. It is some work, but like the nice thing is once everybody's kind of, or, once most people have got it, like the one person who now comes in, like they just kind of absorb it by nature, basically.
Yeah.
I
joined SuperEvo almost 2 years ago, and the decision to use Kubernetes, it was already there. And I think one of the things that really I think I enjoy, I think is related to what Chris mentioned, is the community around it, right? So there is a whole community around it. While not everything might be straightforward or simple, it's easy to kind of navigate through and find a solution for you. I think it's also like, my perception is that it's becoming really standard, in the industry. And then in a way, when you hire someone, most likely they have been exposed to it to a good degree, which helps, right? It's kind of a new, it's just growing the community and easy to learn and everything. So all the things that goes around it, I think is, it's really good to just kind of build on that, your knowledge on that.
Yeah, and while it is huge, and there is a learning curve, people refer to it as a distributed operating system. And I guess in the same way that you would learn Linux, you make sure that you understand your tools, you understand the Kubernetes operating system, and you apply it at a distributed and global scale. So we've got Kubernetes, we've talked a little bit about that. Are there other cloud technologies, be they cloud native technologies or cloud provider specific technologies, that you're starting to see as becoming significant, or at least increasingly important in your workloads?
Maybe not necessarily, cloud related. I think I'm following the trend here with artificial intelligence and machine learning. So I think, because in my opinion, I think it has the potential to really improve our productivity by allowing us to focus on the harder problems. I think there are two aspects, when we are talking about cloud and, maybe gaming, two aspects of it. I think one, really hoping that AI can make our, development process easier. So tools like, Copilot, and really, helping us, making choices in terms of, what the right cloud components and so on. Maybe we're not quite there yet, but that's my hope, at least. And I think there is also the aspect of the operations side of, a large-scale distributed system. I really hope that, in the future we can have more tools, like AI-based tools that can help us monitor and optimize, our infrastructure. At the moment, I think this process of, monitoring, making sure it's cost-effective and is working well, require a lot of expertise and time right? Really observing all the different aspects. And I hope that, we'll have more tools, AI-based tools that can help this process, to improve in development and also the maintenance costs.
Sorry, please go ahead, Viv.
No, I was going to say, another one I think is kind of serverless computing. I think this is something that, at least for me, is more or less, new. So it's just been observing and see how that applies, for us at SuperEvo, for example.
At least from a scaling perspective, you've got the ability to scale from nothing to, I guess the sky's the limit with serverless. So
yes,
I guess that gives you quite a lot of flexibility for, again, another learning curve, but I'd imagine it's a much shallower learning curve than something like Kubernetes. On the subject of AI, though, and here's people thinking they'll be safe from ChatGPT for half an hour. They are not. How much do you trust the AI tools, and do they tend to help within the realm of development, or are you trusting? And I guess, how much can you trust AI at the moment in your workflow? Do you trust it to make larger decisions? Are you having to spend a lot of effort in vetting the output of the AI that you're applying, for example, through Copilot, etc.?
Yeah.
I mean, I'll say I use ChatGPT every day to write code. Like, it is not perfect. Like I ask it a question, like I would, like, essentially it's a rubber duck for me. Like I sit there and I'm like, hey, I'm thinking about doing this thing in PowerShell, and it needs to do this. It needs to use kubectl, and then bloop, there's some code. Now, sometimes, like, especially with PowerShell, like, we use 2 different versions, and it can mix those up and things like that. But, like, for the most part, like, it's there, and I can kind of make sense of it and pick out the pieces that I need to fix, or at least, when I run it, I see, oh, that doesn't make sense. But I would say, like, for the most part, like I will tell you, on Monday, I checked in one file that was entirely written by ChatGPT. Like, I was like, hey, I needed to do this, this, and this. And it even wrote comments, like, explaining what each step was doing and stuff like that. So, like, I trust it in that, like, yes, it's absolutely a tool. I'm not worried about it, replacing my job. Like, it doesn't appear to be, that powerful. But at the same time, I do think that, like, as developers, it's something that will likely become like a tool of the trade, just like Kubernetes, where it's like, hey, I use that and I understand, what people are talking about when they're talking about that. And I expect that, maybe it's not ChatGPT, but I expect that we'll have some, Copilot, whatever AI assistant that is, making our coding a lot smoother and faster.
Yeah. Yeah, I see that more as a kind of a sort of, pair programming tool, right? That is there to assist you rather than, so you still need to use your experience at least these days to, make a good judgment and, kind of decide where to go. But it can definitely kind of, make you a bit more productive. That's my view, so it's to help you there. But I don't think it's there to kind of take your job. Absolutely not.
I quite agree. I think of it in terms of like a very powerful autocomplete.
Mm-hmm. Yeah.
Yeah.
So we've talked a lot about the happy path. We create games, they scale to millions of users, everyone's happy. But what about examples where your teams have encountered unexpected problems? What kind of tools did you use to detect them? And how do you go about solving a large scale production issue at global scale?
Yeah, I can talk about one situation. I think one thing that is very, very, true in a larger scale is that any inefficiency, it will become very visible, right, when we are running in a large scale. So I think it's, as we mentioned, I think it's really important that we invest in observability, just so we are able to quickly detect and resolve those issues in production. So one that I can mention here that I can, remember, we had so part of our code, one very specific one that was using more CPU than we would like to, right? And I think we could see that, it was starting to affect, the liveness of our services, of our pods more specifically. So they were lasting, not as long as we would like them to. And then we went into a process of, just trying to pinpoint what the problem was. It was more like using code profiling, and then we could quickly see, that, there was this part of the code using a lot of CPU. And it was very interesting, the impact that we had when we solved that problem, right? It was perhaps way more than we anticipated. So we had, a reduction in terms of latency, so a better user experience to our players. All we know, we also were able to run, the services much more efficient. So, we reduced the number of pods, I think, by half, maybe, and then, that's very, cost efficient compared to what it was before. So, so something, that perhaps is a small thing, just using more CPU than we would have to, but then overall having a very significant impact to our players and to our, infrastructure cost.
Yeah, I guess you could, on one hand, you could be inclined to say, well, throw more nodes, throw more pods at the problem.
Absolutely.
But actually, by solving it, I guess you achieved greater pod density on your nodes. And probably, especially, I guess you're talking about one service, you managed to halve the nodes, but that's going to be a huge saving.
It does, yeah, absolutely. And in this case, it was one part of the code that was using by more than one service, right? So we saw an impact in different levels because there was a different, pattern of usage on each service. But yeah, it was very significant. Also, I think in keeping things more stable, right? So we didn't, the pods were just lasting longer as we'd like them to, and this sort of thing. So yeah, it's one very specific example of what we experienced in the past.
Yeah, Chris, how about yourself?
Yeah, I mean, the biggest one, probably the most recent one, I guess I can remember, is we had this issue where, so we have we have probably 60 services in our clusters, but we have a few that are kind of like, I would consider the hot path, right? Like getting someone in, getting logged in, playing a game. And one of these services, we found that if we deployed it during a high volume time, it would fall over. Eventually it would get healthy, but we'd see pods just die, and then a new one come up, and then all of a sudden you'd see another one die. And yeah, so, we had to dig in on that. I want to say, if anyone has a better way of doing this, I'm open to it. We didn't love this experience, but we had to essentially take some crash dumps of our pods, and that was difficult in itself, catching the problem in the act, and then actually figuring it out. At the end of the day, it was deadlocking in code, where we had requests coming in, which were resulting in requests going out, but essentially we were just saturating the NIC before that pod could really do finish any of that stuff. And so one would just get locked up. And the way we did it, the way we solved it is actually worse. We essentially warm up our pods now. And so everything is ready to go when it starts taking traffic. Not ideal, because we do want to have quick startup times, but it works for us, especially for these hot path services. But yeah, that was a lot. We had to look at observability again, huge part of it. We were looking at Prometheus metrics, saying, that one, we assumed, when you see that sawtooth of pods are falling over, you assume a memory leak, right? But it wasn't really a memory leak. It was. And so we didn't see that pattern of the memory just skyrocketing and then falling. And so, yeah, that was a weird one, a tough one to dig in. And yeah, if there are tools around grabbing core dumps or anything like that, I would love for someone to ping me on that, because that's something we're very interested in.
Yeah, I guess you were harnessing readiness and liveness health check endpoints for that, which are perfectly suited for Kubernetes environments.
Yep.
I've just realized we are pretty much out of time with this. That time went extremely quickly. I just want to thank you both so much again for all of your insights. This, for me, has been a really interesting panel discussion, and I hope it's been really interesting to everyone who's been watching. I guess we'll leave it there. Thank you again, and thank you to everyone who attended.
Yes, thank you. That was amazing. There are questions, a few of them in the chat, and so do you want to, if you can stick around a little bit, unless you want to ask like one real quick one right now?
We could. Let's see. Why don't we ask one question while we have you, and then we'll just skip ahead. So we have one question, which is, what do you find as a blocker for studios to open source more of their tech when it comes to the platform management?
I think is making sure that, whatever we use in terms of open source, we have, a strong community around it. It's something that we can, really rely for the long term, right? And I think it's understanding, more on the open source tech that we are referring here. And just understanding, how that matches our needs and things like that.
I would add to that it's probably also some of the hidden, I guess, cost of open sourcing something. Like open sourcing can be a fantastic way to get more people involved in your project and things like that. However, in the early days, especially, it's you, and you have to be prepared for that. You have to be ready for that, and you have to be prepared for that to be however long. And so. Like to me, I previously worked at a startup that was open sourcing a few things. And one of those things actually ended up getting unopen sourced because we just didn't have enough people working on it outside of our company. And so we just kind of were like, okay, this is a huge amount of work to make this work in the open source ecosystem. And so we're just going to inner source it again. Yeah, it's just like, I think that is probably the biggest blocker. I don't have a good solution for it, unfortunately, but yeah, that's what I would say is probably the biggest one.
Okay. Excellent. Well, thank you, Rob, Viviane, Chris. This was a great discussion. If you do want to check out in the comments, or if you have any questions for them, I'm sure they're willing to hang around for a few minutes. So with that,
thank you.